So for some crazy reason, I thought it'd be a good idea to go about designing my own doorbell, even though these things can be bought cheaply off the shelf. Well, it might be fun to design one from scratch. So here are some doorbell design criteria, and there's rather more to designing a electronic doorbell than one might think at first. So let's go through the design criteria. First thing, it has to be reliable. Important that whenever you press the button, the doorbell has to ring, so it has to be always responsive. Next thing, it needs to be compact and lightweight, so we want it to be easy to affix to the door or the door frame, perhaps using double-sided tape. And the next thing is we really want it to be wireless. I think this is pretty important. We don't want to be running wires from the inside of a house to the outside just to get a doorbell up and running in the year 2015. Okay, the next thing that is key is very long battery life. Long battery life because we have no wires connecting it to the mains inside, and we don't want to be changing batteries every week or two, every month or so would get annoying. So the key here is that what we have is a very low duty cycle device. The button's only pressed once or twice a day or so, and the rest of the time this thing is not doing much at all. So it needs to have a very low quiescent current or very low standby current. And we want it to operate until the batteries are very flat. So most batteries have a discharge curve, and they'll taper off at some voltage, so the voltage isn't steady throughout the discharge of the battery. So we want it to operate right down to when the battery reaches its terminal battery voltage, or the voltage, the minimum voltage that it gets to once we've used up pretty much all its capacity. Okay, so we have some design choices before us in order to meet those design criteria. And the design choice I made was to use a 433 MHz transmitter module. These things are ubiquitous, they're cheap, they work. You know, other devices operate in that range and can interfere with them, but the great advantage is that you can fire them up, transmit your little packet, and there's no signing onto a network. So, you know, one option you might consider is a Wi-Fi or something like that. There's going to be quite a lot of delay signing onto the network, getting assigned an IP address, and so on and so forth, when what we want is for the doorbell to be nice and responsive. So a 433 MHz transmitter module it is. And these devices need at least 3 volts, so this will start to influence our choice of power source. So they're typically spec'd between 3 volts and 12 volts. Running them down the lower end is no problem, so you know we can get away with a power source that delivers about 3 volts. We're going to switch it on with a P-channel MOSFET. So one thing is that we don't know what the quiescent current is of one of these transmitter modules, but to play it safe, what we can do is cut the power to it when it's not running. So I've opted to use a P-channel MOSFET for that. Basically cuts the high side or the positive side of the supply to this module when we're not using it. Next thing, well, it makes sense to use a microcontroller to do this kind of project. I've opted for an MSP430G2211. So what's the advantage of that? Well, that device came with the Texas Instruments Launchpad. It's a low-cost programmer that I already had on hand. The other thing is that the MSP430 have a bunch of sleep modes. I'm pretty accustomed to using low power mode 3, and that consumes about a microamp or so when that microcontroller is in LPM 3. So that's not going to impose a great drain on the battery when the device is sleeping. You can go one step further and go to LPM 4. Haven't played with that yet, but that's a possibility to look at for even less current draw. There's enough I/O pins, so a doorbell isn't a terribly demanding application. We really only strictly need one pin to monitor the button press and one pin to control the transmitter module. And these devices operate from about 1.8 volts to 3.6 volts. So that's going to fit quite nicely with our transmitter module requirement of 3 volts plus. And we can have this device always on. So because it consumes so little power, we can have it permanently connected to the battery via a low dropout regulator, which I'll get to shortly. Next thing, we need batteries. A bunch of different possibilities with batteries. We could try coin cells, we could try lithium batteries. They have a voltage around about 3 volts. We could try rechargeable ones of those, like lithium ion cells, or we could try disposable ones of those. I opted for 3 AA batteries because, well, that will give us about 4.5 volts. They're easy to get. So when fresh, they'll give us about 4.5 volts and about 3 volts when flat. So even when they're totally exhausted, they'll still provide a satisfactory amount of voltage to power our transmitter module. And this, however, necessitates a voltage regulator. So if we plugged 3 full up AAA batteries into an MSP430, we'd cook it because the MSP430 expects a maximum of 3.6 volts. We'd be putting 4.5 volts across it. So we need a voltage regulator. I opted for the MCP1700 at 3.3 volts. It's a low dropout regulator, and it has a low quiescent current. So the datasheet claims about 1.6 microamps as being typical. So that means we can have our microcontroller in sleep mode being powered off this low dropout regulator and only be consuming a few microamps in that state. And so this device will always be on, so this is a key consideration, to have a low standby current. It'll drop out of regulation at the end of the battery life. So if we're saying that our 3AA batteries give out about 3 volts when flat, that's going to be below the 3.3 volt output of this regulator. But that's not a problem because, well, we're not going to cook the MSP430G2211. The transmitter module might start to fail, but that's okay. By the time this happens, many years will have passed and we'll know that it's time to replace the battery. So that's the design that I've come up with, informed by the design criteria above. Having taken a look at the design considerations, here's a sneak peek at part 2 of this series when I take a look at the schematic and initial prototype for this project. Till then, please like and subscribe and stay tuned for part 2.